Okay, welcome to this video where we're going to be having a look at the Edexcel paper 2 topics that come up on the advanced information. Now, as you can see on the screen, I've put together the revision lists for you, so if you want to access the revision list no matter what exam board you're on or no matter what exam tier you are doing, you can access those by clicking on the description, and it's the top link that says the Higher Foundation checklists, and you can just download whichever one you need. Now obviously I'm only going to be going over one type of question for each topic, so you do need to do your own research, do your own revision, have a look at your exam guides, make sure that you're listening to what your teacher is asking you to revise as well. But hopefully this should give you a good guide and something to have a look at in terms of your revision and figuring out maybe which topics you need to put a little bit more work into. Now obviously paper 1 is already released, so you can find the links to all the papers as they come out in the description, so make sure that you have subscribed to the channel, and obviously if these are useful and helpful, don't forget to like the video and don't forget to drop me a comment and let me know if there's any other topics that you'd like me to go into more depth for. Now as with all the others, I'm going to very quickly show you how the video works, so let's have a quick look at that now. Okay, so when you are on the video, if you click onto the description, as I was just saying, you can see just there at the top it says the Higher Foundation checklist, and you can click onto that and download whichever one you need. Just below that you can see that I will have the links there for the foundation and the higher papers, so you can click on whichever one you need, save it, bookmark it, whatever you need to do, and you can use those throughout the year. As well as that, if you scroll down, you'll see that I bookmark each topic, each chapter, and put the link to the full lesson next to it where I have made the full lesson. So you can click on any of those and look at any further topics in a little bit more detail if you need to. You can also see, if you pause the video, down the bottom left there, they're all chaptered, so you can skip through the video, having a look at whichever topic you need to whenever it is that you want to have a look at them. So that's how this video works. If this is the first time that you're seeing one of these, hopefully that's useful and helpful, and let's get started. Okay, so in this question it says James buys 30 pencils, 30 pens, 30 rulers and 30 pencil cases, and then it gives us the price for different amounts. So we can get 6 pens for 82p. So if we start with that one, we're going to buy 30 of those. So if 6 are going to cost us 82p, we would want to multiply that by 5, and that would give us 30 pens. For the pencils, 15 are going to cost 45p, we want 30, so we'll times that by 2, that will give us 30. The rulers, we've got a price for 10, so we'll times that by 3. And the pencil cases, we've got the cost per pencil case, so we're going to need to multiply that by 30. It says what is the total amount that James is going to spend. So if we work these out, if we times 82 pence times 5, and on my calculator I'm going to type that in as 0.82, and multiply that by 5, so I get my cost in pounds. So 0.82 times 5 comes out as £4.10. Don't forget on your calculator that will come out as 4.1, but we want to write that in terms of money, so £4.10. For the next one, we have 45p times 2. I'm going to do the same thing. I'm going to write that as 0.45, multiply that by 2, and it gives us 0.9, which is obviously 90 pence, or 0.90. For the next one, we've got £1.25. We're going to times that by 3. So again, 1.25 multiplied by 3, and that comes out as £3.75 or 3.75 on the calculator. And then for the last one, 0.37, times that by 30, and we get our final bit of working out there, 0.37 times 30, and that comes out as £11.10 or 11.1 on the calculator. So we need to add all of those together. That's going to give us our total cost. Again, we're doing this on the calculator, so add £3.75, add 0.9, add 4.1, and that gives us a total cost there of £19.85. And there we go, there's our first question. Okay, so writing these temperatures in order of size. Now we've got negative numbers involved in here as well, so we're looking at kind of ordering integers, and we're looking at negative numbers. So we're going to start with the biggest negative, and that is the -5. So we'd write the -5 first, then we're going to look for the next biggest negative, which is -2, and that's the last of our negative numbers. So we're going to find our smallest positive number, which is 3 degrees. Then we're going to find our next smallest, which is the 7, and finish off with our 10. So don't forget, when you are ordering numbers and you have negatives involved, you're just going to look for that biggest negative to start with, which in this case was -5. And there we go, that's ordering some negative numbers. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12. And we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6, and we get 1/2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same, we flip the second one over, and we multiply them together. So times in the top numbers, just like before, 2 times 5 is 10, 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and that same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7/4. And we're going to add to that this 2/3, and again, if that was a mixed number, we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom, so we can times this left fraction, top and bottom, by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12, so 7 on the left times 3 is 21/12, and on the right, 2 times 4 is 8/12. And now we can add these together, and again, if we were subtracting them, we'd just subtract those numerators now, but we'll add them together and we get 29/12. And again, it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice, up to 24, and there'll be a remainder of 5/12. And again, there's my final answer. Just be very, very careful at this point, just to have a look. Does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12. That would actually simplify, wouldn't it? Because if it was 4/12, we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation. Does it simplify? This one obviously doesn't. It's 2 5/12. Let's have a look at another one. So when we are putting fractions in order of size, if it was a non-calculator question, we'd be looking to make a common denominator. Now, if you look at these fractions, we've got 4, 7, 25 and 15. Now, there's no obvious number that stands out there as a common denominator that we could use. So as we're using a calculator method here, the easiest thing would be to turn these fractions into decimals just by typing them into your calculator. So if you type in 3 divided by 4 on the calculator and convert that into a decimal, so if you're using a Casio calculator, you can press that S to D button. If not, hopefully you can just get it straight into a decimal using another method, but that comes out as 0.75. 5 divided by 7 as a decimal comes out as 0.714, and a few more decimals after that. We'll come back to it if we need to. For the next one, 9 divided by 25, that comes out as 0.36. And for the last one here, 11 divided by 15, that comes out as 0.73, and there's a recurring above the 3. So in regards to that second fraction that we converted, we're not going to have to go beyond the 3rd decimal place there, as we can make a comparison just by looking at them as they are at the moment. So the smallest one is clearly the 0.36. So that's going to mean the 9/25 is our smallest fraction. So we'd write that one first and make sure we write the original fraction and not the decimal that we've used to help us. So that one's done. The next smallest is the 0.7 with the 1 after it, so this one here, the 5/7. So we're just looking at that second decimal place at the moment. That's 5/7. The next one, this decimal at the end had a 3 in the second decimal place, so that would be 3rd. So that would be 11/15. And then our final one, which had a 5 in the second decimal place, would be our final one, or our largest fraction there, and that is 3/4. And that would be our final answer there, getting our fractions in order of size, starting with the smallest. Okay, so this question asks us to write down a multiple of 6 that's between 40 and 50. Now, if you don't know your 6 times table perfectly, you could probably jump up to a number that you do know. Now, 6 times 6 is 36. So we could start at 36 and just kind of work up in terms of a sequence. So if we add 6 to that, that would become 42. Add 6 to that again would be 48. Add 6 again would give you 54. And obviously the only two that are going to be important to us would be 42 and 48, as they are between 40 and 50. But of course this question does say write down a multiple, so it doesn't want us to write down both of them, it just wants to write down one. So you could take your pick. I'm going to pick 42, so let's just say 42, and that is a multiple there that is between 40 and 50. And just being careful to read the question if it says write down a multiple, or if it says write down all the multiples. So there we go, that's how we would approach that question. Okay, so looking at some rounding, and we're going to look at rounding significant figures. Of course, you could be rounded to decimal placing or you could be rounding to decimal places as well, but we'll look at significant figures as they tend to be the ones that are not answered quite as well. So for this first one here, we've not got a decimal number involved, we've got 7,357. Now, if we're going to round that to 3 significant figures, we just need to look at where the third significant figure actually is. So the 7 is the first, then the 3, and then the 5. And that 5 is in the tens position. So in the case of this question here, we're going to actually round this to the nearest 10. So looking at the number after that is a 7. So if you do your little rounding line after the 5, and that 7 is obviously 5 or above, which means it's going to round the 5 up to a 6. So that's going to become 7,360, rounding it to the nearest 10. Obviously there was 2 options there. It was going to go to 7,350 or 7,360. And because of that 7, we're going to round it up, and there is our final answer. Now the next one here does have a decimal in there, but we treat it in the same way. So we've got 2.456, and we're going to round that to 2 significant figures this time, and the second significant figure is the 4. Now that is in the first decimal place, so again if we translate that, it just means round it to 1 decimal place. So that's going to be 2 point, and it's either going to be 4 or 5. So again, looking after the line, that is a 5 after the line, so that means it's going to round up again. So our final answer would be 2.5, and that would be rounded to 2 significant figures, which also meant 1 decimal place in this particular question. Okay, so this question says Carla rounds a number x to 1 decimal place, and the result is 7.2. Write down the error interval. So when we're writing the error interval, we're going to put that letter that's given to us in the middle, so we'll put x in the middle, and on either side of it we're going to have an inequality symbol pointing to the left. Now on the left we're going to write down our lower bound, and on the right we're going to write down our upper bound, and we're going to think about these symbols a little bit more once we've written them down. So in order to go for 7.2, we're going to think, okay, well what's the number above that, and what's the number below that, and they're called the lower and upper bound in case of its rounding. So 7.2 is in the middle of 7.3 and 7.1. Now in the middle of those numbers, in terms of the rounding, we look at the 5s, but after that number. So this would be 7.15, and this would be 7.25. And they're the bounds that would allow us to round to 7.2. So 7.15 is the smallest that the number could have been, and 7.25 is the largest the number could have been. Now we've got to think about this a little bit carefully, because 7.15 would in fact round to 7.2. So on the inequality symbol we can put a little equal to symbol as well, because it can actually be equal to 7.15. Well, that's not the case for 7.25, because 7.25 to 1 decimal place would actually round to 7.3. So we don't put an equal to symbol with that inequality, so we're going to leave it how it is, and that just means it's got to be less than 7.25. So there we go, that's looking at error intervals. Okay, so this question says for each statement below, put the correct symbol from the following. So we have less than, greater than, or equal to. So for the first one, 3.4 is less than 3.6. So we put the less than symbol there. For the next one, -2 is actually greater than -3. So we put that -2 is greater than -3. And for the next one here, we've got to be a little bit careful. It says 25, and here we have -5 squared. Now when you square a negative number, you should actually put it in brackets, particularly if you are using a calculator. So if we do negative 5 squared, that actually comes out as 25. And we should know that already because a negative and a negative multiplied together make a positive number. So they're actually equal to one another. So there we go, that's what we would do if we were putting some mathematical symbols into some statements like on this question. And again, just a little reminder there on being careful when you are squaring a negative number. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12, y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately, so let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Okay, so factorising, we're going to take out a factor and put this into brackets. So we have a look at both these pieces, 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus, and 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have two things, and let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? We'll have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared. So I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that. And there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to solving simultaneous equations. Now we've got two equations here. I'm going to call this one 1 and this one equation 2, just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. Now I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y, that would become a plus and I'd end up with 6y. So taking them away is not going to work. I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do 4 lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. If we solve this like normal, taking away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here if I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7 we have negative 3y equals 9 when you take away 7, and then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2. Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of B the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think, we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that would give me a 12 in the middle. So if we actually work that out, let's have a look. What do we get? Timesing the top one by 3, and let's move this around. Okay, so times in the top one by 3, we get 9c plus 12b, and 23 times 3 is 69. Onto the one below, times them by 4, we have 8c plus 12b, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69 take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides. And we get 4b equals 23, take away 15 is 8. And then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5 and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now there's two ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2, and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3, double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for 2 coordinates here. I've got 1 coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in 1s, sometimes you might have 2 squares for every 1, so just be careful of that. Now it goes across 1, and then it goes up 2. So it goes across 1 and up 2. So every 1 across it goes 2 up. So the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at negative 3. So c is going to be negative 3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through negative 3 on the y-intercept, and there's a gradient of 2 which are found between those two whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'll take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick two coordinates. We've got one here and one here, and now this time for 1 across it goes 2 down, so 1 across it goes down 2. So my gradient this time is going down, and we'd say it's negative 2, so the gradient is negative 2. So y equals mx plus c, we have y equals negative 2x plus the positive one there for the y-intercept, and there's the equation of that line. Okay, so when looking at a number machine, we have an input and an output. So this number machine here, when you put the input in, you multiply by 3, subtract 4, and you get the output. So for part A on this question, it says find the output when the input is 5. So when we put 5 in, you multiply it by 3, and if I just write that here, and we get 15, and then we take away 4, and we get an output of 11. So for the first answer there, our answer would be 11. Now for part B, we're looking at it the other way. It says find the input when the output is 35. Now if the output was 35, the last thing that would have happened is we would have subtracted 4. So if instead of doing that we go backwards and we add 4, it must have been 39 before we subtracted 4. Now for the next step, we obviously, before that, multiplied by 3. So to reverse that, we would divide by 3. So if we divide 39 by 3, we get an input of 13. And again, you can check that going back through the number machine, because 13 times 3 would equal 39. Take away 4, that would give us 35. So our input must have been 13 for the output of 35. And there would be our two solutions there when looking at using a number machine. Okay, so there are lots of different conversions that we can look at, and there are lots of different versions of each of these conversions. So when we are looking at this, if we want to convert 3.45 kilograms into grams, we need to know that there are 1,000 grams in a kilogram. So if there are 1,000 grams in each kilogram, all we would do would be to multiply this by 1,000. And if we multiply that by 1,000, you can obviously type that in on your calculator, and it becomes 3,450, and that would then be in grams. If you are moving the other way, so let's say we were converting 3,450 grams into kilograms, we would simply divide by 1,000, and that would be one of the conversions when we are looking at mass. When we are looking at time, we have slightly different conversions, because in each hour, we are going to have to multiply by 60 to turn that into minutes. So if we have 2.5 hours, we just need to multiply that by 60, and of course you can just type that in on your calculator as well, and that comes out as 150 minutes. So obviously looking the other way as well, if you want to convert that amount of minutes back into hours, you can divide by 60, and that will give you the answer 2.5. Now when it comes to area or volume conversions, these are a little bit more tricky. So when we are converting with areas, we need to think about the original unit conversion. So what I mean by that is to get from meters to centimeters, what do we actually do? Well, in that conversion, we do times by 100. Now, if it is meters squared to centimetre squared, instead of timesing by 100, we just times by 100 squared. And that would apply as well if it was a volume conversion, so we'd times by 100 cubed instead. So for this one here, if we're converting 3.2 into centimetres squared, we just want to times that by 100 squared, and you can just type that in on your calculator, times 100 squared, and we get the answer 32,000. And that would be our conversion into centimetres squared. Now again, just like the previous ones, if we're doing that in reverse, so let's say we're turning centimetre squared into metre squared, instead of timesing by 100, to go backwards here, we would just divide by 100 squared. So you can obviously check that out. You can do 32,000 divided by 100 squared, and you'll see that you get 3.2. So knowing these conversions are quite important, and obviously knowing just to add the squared onto there if you are converting between areas can really help, obviously, particularly as you can just type this into your calculator. Okay, so when looking at scale drawings and scale models, we are given that the length of a car is 3.6 meters. It says Carl makes a scale model of the car and he uses a scale of 1 centimeter to 30 centimeters. And that could also be written as a ratio. It could be written as 1 to 30. Now it says here, work out the length of the scale model of the car and give your answer in centimetres. So to start with, we should notice that this is currently in metres. So after we've looked at with our unit conversions, we want to convert that into centimetres, and we can do that by multiplying by 100. So in terms of centimetres, that would equal 360 centimetres. Now it says in the conversion, or the scale here, that for every 30 centimetres, the model's only going to be 1 centimetres, or the other way around. For every 1 centimetre on the model, the real car would be 30. So in order to do this, we're going to have to just simply divide by 30, and that's going to convert it down to our scale. So for 360 as the real length, we're going to divide it by 30, and that's going to give us our final answer, and that comes out as 12. So for our scale model of the car, the length of that is going to be 12 centimetres, and that would be our final answer. And again, that's just using it as a ratio, 1 to 30, or just in words there where it says that every 1 centimetre on the model will be 30 centimetres in real life. So there we go, that's how we look at scale drawings. Okay, on to writing some decimals as percentages. Now when we're writing decimals as percentages, any decimal can be converted into a percentage on the calculator by just multiplying by 100. So these are really nice and quick and easy to do on a calculator, because we can just do 0.7 times 100 and it gives us our answer, and it comes out as 70%. Now again, we can do that with this one below, 0.24, you can times that by 100 again, and it just straight away gives you your answer, and it comes out as 24%. So there we go, converting decimals into a percentage, nice and easy for us to do, and we can do that in any type of question. Whenever we get an answer as a decimal and we want to write it as a percentage, you just multiply by 100. Okay, so this one's a little trickier. It says James buys 6 kilograms of sweets for £10. He puts them into 250 gram bags and sells them all for 50p per bag. Work out James's percentage profit. Now for starters, we've got a little bit of converting units in here, hopefully nothing too horrible though. We've got 6 kilograms and we've got 250 grams. So we'd probably prefer to write this in grams. There are 1,000 grams in every kilo, so that would be 6,000 grams. So now we know how many grams he's bought. He's going to put them all into 250 gram bags, so we could work out how many bags he's actually going to have to sell. So if we divided that by 250, that would actually calculate for us how many bags he's actually got. Now there are 4 lots of 250 grams in every 1,000, and we have 6 of those thousands. So if we do 6 times 4, that gives us 24 bags. And again, you can take your time working that out, but every 4 250 grams is going to add up to 1,000, and we have 6,000, so 6 of those 4s is 24. So 24 bags of sweets, and he's going to sell them for 50p. So we've got to do the 24 bags, and we're going to multiply that by 50p. And again, you have to take your time here. Now I am going to do a little trick here, and that is because I know if I do 24 times a pound, that'd be 24 pounds, and 50p is half of a pound. So instead of being 24 pounds, it's going to be half of that, which is going to be 12 pounds. So that's going to come out as 12 pounds. But again, you can obviously just do your working out to the side. You only actually have to do 24 times 50 using column multiplication. Again, we get 0 and 0, put our placeholder in. 5 times 4 is 20, 5 times 2 is 10, plus the 2 there is 12, and then add it all together and you get 12 or 1,200 pence, which comes out as 12 pounds. So don't worry about doing your working out to the side. In fact, I definitely encourage it here, but I just applied a little trick there, just to obviously put a little bit less writing on the screen for you. So £12 is what we're actually selling it for, and don't forget that we actually paid £10 for these sweets. So if we had £12 that we sold them for, £10 that we bought them for, that is going to be £2 in profit. So we've made £2 profit. There we go. So to work out our percentage profit then, this is quite a nice one because our profit was 2 out of our original, which is 10, and that is straight away going to be 20%. So there we go, that's 20%. And again, you could multiply the numerator and denominator there by 10, so it's 20 over 100. But ultimately, we get our final answer, which is 20%. And again, you could take that original approach, and that is to work out 10% of 10. Obviously, and I keep doing this on every question for you. So 10% is 1. We want £2 profit, which is going to be double that. So 20% is £2, and there is your other method, which works every time for these as well. Okay, so this question says, Amy buys a new car for £18,000. Each year the car depreciates by 12%. How much will the car be worth at the end of 3 years? And obviously we could do this without a calculator, but we're going to have a look at doing some calculator methods here. So obviously the original value, in terms of a percentage, is 100%. Now if it loses 12%, so let's just say, okay, well we lose 12%, what percentage are we actually left with? And 100 take away 12 is 88%. Now there's actually something we can do here, because if it's going to be 88% of its value each year, there's something we can just times by straight away on the calculator, and it's the decimal version of 88%. And the decimal version of 88% is 0.88. And straight away, if we just times by 0.88, it will actually take away 12% for us. I can do that on the calculator, 18,000 times 0.88, and it gives me the answer 15,840. So that would actually just reduce it for me in the first year. And I could just do that 3 times. I could just times by 0.88 and keep on repeating that. Or I can actually do something to speed things up a little bit. And it's very similar to compound interest. And with compound interest, this is something that you add on to this multiplier here to get your 3 years. And it's a power of 3. So if I want to actually do this just 3 times very quickly on the calculator, I can do £18,000. And I can just times it by 0.88, and again I could do it 3 times, or just to speed things up a bit, you can just add a power of 3. Okay, and that will just be the same there. If it was 4 years, you'd put a power of 4, 5 years, you'd put a power of 5. Okay, and it'll just do it that many times for you. So if I type that straight into a calculator, 18,000 times 0.88 to the power of 3, and I get this answer here. I get £12,266.496. And obviously we are talking about money here, so we're going to have to round it to the nearest penny. So a final answer would be £12,266, and I'm just going to follow the normal rules of rounding, so I'll chop it off after the 9, and that rounds up to 50p there. So that 9 rounds up because of the 6, which rounds it up to 50p, so 0.50, and that'd be my final answer there. Again, just rounding to the nearest penny on any of these questions. Okay, so that's how you do it nice and easy on the calculator. Again, just thinking about the percentage, let's just pick a random one. If it depreciated by 23% each year, 100 take away 23 would leave us with 77%, and as a decimal, 77% is 0.77, so I'd times by 0.77. So just something to be thinking about there. Whatever the percentage it depreciates by, you can take that away from 100 and then convert it into your decimal that you're going to want to multiply by. So just a little bit of a quicker way that you can do this rather than having to do all those stages of each year. Okay, so when we are writing a ratio, it says here, write down the ratio of 450 grams to 15 grams. Give your answer in its simplest form. Now, of course, both of these are given to us in grams, so we can straight away write it as a ratio, but of course they might have been given in different units, and that would be fine for us to do as well. Like, for example, the 450 grams could have been written in kilograms, and we would have obviously had to convert it first, but as these are the same, we can straight away write that as a ratio. We would write it as 450 to 15. Now, of course, this one here says to give your answer in its simplest form. And if you are doing this on a calculator, it's really nice and easy. If you have the fraction button on your calculator, you can just write it as a fraction. You can write in, that's why I normally put the smaller number on the top, 15 over 450, and then actually simplify it for you. And if I type that in on my calculator right now, it simplifies it down to 1 over 30. Obviously you're going to match these numbers up in the correct place, so the 15 became 1 and the 450 became 30, so our simplified ratio there would be 30 to 1. Obviously if you don't spot that, or you don't have that function available on your calculator, you just have to divide it down, and in this case it was just dividing by 15, which you can just type into your calculator just to make sure that you fully simplify it. And there we go, that's our final answer. A nice little trick there to use your calculator to simplify a ratio if something like that comes up. It says here that 5 boxes of cereal have a total weight of 1,750 grams. It then says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490 grams. Work out the total weight of 3 boxes of cereal and 2 sachets of sugar. So this question's different because we have 2 different variables. We have the cereal and we have the sugar. So we need to figure out one of them first, and let's have a think about which one we can work out straight away. Because that first line just says about one of the variables, it just says 5 boxes of cereal have a total weight of 1,750. So we can work out one of the boxes by dividing that by 5. So let's just have a think. We've got 5 boxes is equal to 1,750. So our first step to get the weight of one box would be to divide that by 5. So we will divide it by 5 and we'll do our working out to the side. So 1,750 divided by 5, well 5 goes into 17 3 times, remainder 2, goes into 25 5 times, and then 0 at the end. So the weight of one box is going to be 350. Of course this is in grams. And the final part of the question, which we don't have to work out straight away, but it wants us to ultimately work out the weight of 3 boxes. So straight away we could multiply this by 3, and again you could work this out at the end once you've got the singular weight for both, but we may as well just straight away times that. So 3 boxes, and that is going to be 3 times 350. 2 times 350 is 700, add another 350 is 1050. Again, you could spend some time just adding 3 of them together using column addition or multiplying it by 3, but there we go, we have the weight for 3. So let's get rid of this working out and move on to our next piece of information. So the next part is obviously we have the sachets of sugar. So for this second line here, it says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490. Well, if we work out the weight of 4 boxes of cereal as we know the weight of 1, then we could have a look at working out therefore what the weight of the 3 sachets of sugar are going to weigh. So if one box is equal to 350, 4 of those boxes is going to be 1,400 grams. And obviously it says in the question that the weight, including the 3 sachets of sugar, is 1,490 grams. So that is going to be adding another 90 grams. So those 3 sachets of sugar are equal to 90 grams. So we can write that down. So 3 sachets is equal to 90. Of course, we want to break that down and go back to 1 sachet. So we can divide that by 3. So if we divide that by 3, we're going to get that 1 sachet is equal to 30. There we go. And obviously the question here, and we'll swap colour again, wants us to work out the weight of 2 sachets of sugar. So we can straight away multiply that by 2. And if we multiply that by 2, we're going to get that 2 sachets is equal to 60. And that is the second part of our answer. Now, of course, this question here said work out the total weight of 3 boxes and 2 sachets. So we're going to want to finish this off by writing the total weight. And that is to take our 1,050 and our 60 and add them together. So for our final answer, we'd do 1,050 plus the 60, and that is equal to 1,110. And that is in grams, and that is our final answer. So quite a lot going on in that question. Obviously we had to work out the weight of one of the variables, then we used that to help us find the weight of the other one, and then once we'd found the weight of a singular amount for both, we were able to multiply them and work out the total weight for 3 of the boxes and 2 of the sachets. Okay, so this question says identical pairs of boots are sold in London, Geneva and in Paris, and the handbag costs €174 in Paris, £115 in London and 189 Swiss francs in Geneva. And it says the exchange rates are, we've got £1 is €1.27 and 1 Swiss franc is 72 pence, or £0.72. In which city are they best value for money? Now obviously we're going to get them in the same exchange again, in the same currency, but this one here always tends to throw people because that is a bit of an odd exchange rate. That kind of exchange rate is the exchange rate we would be given if we were actually in Geneva and we were wanting to convert our money back into pounds. So it's not one that we see very often because normally it's always £1 to whatever the other currency is. So this is a little bit different, but again, all we're going to do is apply a bit of logic, and this is why I don't remember just times or divide for particular ways, because if we are given an exchange rate like this, we have to think logically about the size of our answer and which one logically is going to be bigger or smaller in terms of the number. So again, I'm going to take the same approach. I'm going to leave London as it is, as £115. I'm going to look at Paris and Geneva. So I'm going to start with Paris. Okay, so Paris, we need to convert the €174 into pounds. Now again, looking at the exchange rate, okay, so down here our exchange rate, the pound is now to €1.27, so the euro number is higher. So I need to divide by that exchange rate, so 1.27, in order to get it back to the smaller pounds number. I've got to be careful with the language that I use, because obviously it's the same value, but in terms of the size of the number, it is smaller. So divide it by 1.27, and I get, and it's a nasty decimal, and don't be put off by that, I get 137 point, and then it's 007, so to the nearest penny, that would be 01. Okay, so it's a 7 after that in that third decimal position. So obviously that's now in pounds, so we've got 137.01. Now we can already see that that's not better off than buying it in London, so we can also almost forget about that one now. And now we're going to have a look at Geneva. There we go, so in Geneva, let's have a look. The cost at the moment is 189 Swiss francs. Okay, so 189. Now thinking about the logic of this exchange rate, you can see that for every 1 Swiss franc we get less than 1 pounds. So we know again that the answer in pounds is going to have to be smaller, but this time if I was to just divide, which obviously some people tend to remember it like this, you divide coming back home, you times when you're going away, but because this is the foreign exchange rate, if I was to divide by 0.72, which I'll do on my calculator now, 189 divided by 0.72, I get the answer £262.50, and that is a lot higher. Okay, so when we've got the foreign exchange rate, we have to almost reverse the process and think logically, and actually it's just logically okay, well dividing didn't work, so we're just going to multiply by that exchange rate of 0.72. okay, and obviously that's what you'd do if you were actually in Geneva and you were obviously going off on holiday to London, you would multiply by the exchange rate. Okay, so it's just giving us their exchange rate rather than our own. So 189 times 0.72, and that gives me an answer here of £136.08. There we go, so it's £136.08. There we go. So actually, as you can see, all of that working out, and actually it is just best value to just to buy these boots in London. Okay, so obviously these questions will normally say you must make sure you show all your working out, and there we go, that's all our working out there. So even though it's still in the London one, we're going to say it's best value in London. There you go. The boots are best value in London. There we are. Now obviously you could have taken a different approach here, you could have converted them all maybe into another currency. It wouldn't actually, I don't think we could have done with this one in particular, because we don't have any exchange rate here between them, although we could have maybe converted Paris into the Paris amount into pounds and then into Swiss francs, and also converted the pounds into, we'd have had to do it in 3 steps rather than 2. So it was the most sensible idea in this question to convert them all back into pounds, but you could have actually gone about trying to convert them all into euros or into Swiss francs as well, but it just makes sense to always convert it back into our own currency, obviously. Just makes a little bit more sense when it's on the paper. So it says that A to B to C is a straight line, so that tells us that these two angles next to each other have to add up to 180. So that's something we might use at some point. But it says work out the size of angle, and it gives us something different here. It says angle BDC. So to find angle BDC, you go from point B to point D and then down to point C. And you can see that by drawing that, it has created this angle just here. So that is the angle BDC, and that is the one we're actually going to be looking for. So again, you can obviously trace your finger over the shape to find that at any point. So let's think about that. We've got a triangle on the right there, this one just here, which is a scalene triangle. There are no lines on that particular one. There is a line just here, obviously because this triangle on the left is an isosceles, but that line there doesn't necessarily relate to the triangle on the right. So the triangle on the right is a scalene triangle, all the angles will be different or could be different, and on the left here we've got an isosceles. So because we have that top angle in the isosceles, we can definitely work out these two base angles. Again, just finding the ones underneath those two little lines. So at the moment there's a top angle of 70, so if we do 180 take away 70, it's going to tell us what's left to be split between the two base angles, and that is adding up to 110. So if we divide that by 2, that will split it into our base angles, and 110 divided by 2 is 55 degrees. So both those base angles are 55. Now that's going to allow us to move into the other shape. As we mentioned at the start, these two angles just here are going to add up to 180. So to find this angle just next to the 55, we would do 180 and take away 55. and that gives us an angle of, and again you can do your working out for this, but that gives us an angle of 125 degrees. So this one here is 125. And now you can see we have enough information on this right hand triangle to find our missing angle, because we now have two of the other angles. So if we add those two together, we've got 125 and 29. And if we add them up, that adds up to 14, 5 and 1, so 154 degrees. And we want to take that away from 180. So to finish this off, our final bit of working out, we'll do 180, take away 154. And again, if you can do these mentally, that's absolutely fine, but we'll just do our written method for the purpose of this video. 10 take away 4 is 6, 7 take away 5 is 2, and 1 take away 1 is 0. So that final angle there is 26 degrees, and that is the final answer for our question, because there we have found angle BDC. Okay, so working out the size of angle X, again I've got two here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are three rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So X would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110, because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75, because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these two symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these two little, what I call little eyebrows. Okay, so underneath, this will also be 75, because base angles in an isosceles are equal. We can then find this missing angle here, because angles in a triangle equal 180, so those two 75s equal 150, and if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now, to get that angle X, there's a couple of ways we could do it. We could find this angle here, and then do angles on a straight line. Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say X equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So working out the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360, 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2, so 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign, let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously, we're concerned about this little area here in this question, because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees. And again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got 2 of these angles, kind of like a jigsaw. So if we add these 2 together, 120 plus 135, at the moment we've got 255 degrees, and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. So when we're looking at circles, there's 2 formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared, and we just need to know what the radius is. So over here the diameter is 8, so we're going to first halve that for the radius, so I'll just write r equals 4, and we'll just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16, and you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that, but we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50 point. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared, and that'd be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes, and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is -2. Now -2 moves down towards the negative numbers, so 1, 2 down, and that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2. And there we go, we can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point -1, 0. So first thing to do is obviously to locate that point, which is -1 across, not up and down. So -1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in. So trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees. So it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape. Let's have a look. It would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description, you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just set a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so the probability that Amy wins a game of snooker is 0.2. Amy's going to play 2 games of snooker, work out the probability she wins exactly 1 game. Now let's have a look at this one. So if we create a probability tree for this, we've got on that first game, which I'll label this branch as the first, she either wins or she loses. And the probability she wins is 0.2, and the probability that she loses is 0.8. Now she's going to play a second game, so I'm going to have a second branch. Again, this is after she's won, and we've got a second branch here in case she loses. But again, she wins or she loses, and she wins or she loses. Now it doesn't say the probability changes on the second game, so it's all just going to be the same. 0.2 for a win, 0.8 for a loss, and the same below. 0.2 for a win, 0.8 for a loss. Okay. So it says work out the probability she wins exactly 1 game. So she wins exactly 1 game, that's quite important there. Now the only way that she wins exactly 1 game is if she also loses a game. So this win-win up here is no good, and this lose-lose down here is no good. But here we've got the probability of a win and then a loss, and then here we've got the probability of a loss and then a win. All we need to do is work out these 2 probabilities. So to get to this second branch here, if we go to the start, we go up through the win, and down through the loss. So that's 0.2 multiplied by 0.8. And 0.2 times 0.8 is 0.16. Looking at the second option there, she could lose and then win. And that just goes through 0.8 multiplied by 0.2, which gives us the same answer there of 0.16. So we've got our two answers there. We've got 0.16 for that route and 0.16 for that route. And when we've got two probabilities to combine, we just add them both together. So 0.16 add 0.16 gives us a total probability there of 0.32 as our final answer. So another probability question. James takes the bus to school. The probability his bus is late going to school is 0.3 and the probability his bus is late going home is 0.7. What is the probability that at least one of his buses is late? Let's have a look at creating a tree. So this time it's not the same thing on both occasions. We've got one where he's going to school and the other part of the branch is where he's going home. But when he goes to school, it's either late or it's not late. And the probability of late is 0.3, so therefore the probability that it's not late is 0.7. Then we've got the next branch, which is going home. Now the numbers look quite similar here because we've got 0.7 in there again, but we've got late and not late, and again, late and not late. But this time it says going home, the probability that's late is 0.7, so this would be 0.7, and again 0.3, and the same below, so 0.7 and 0.3. Now the question says to work out the probability that at least one of his buses is late. So this time it's not just one late, it could be late on both. So we could have the probability, let's do this in a different colour, we could have the probability that it is late and then late. We could have the probability that it is late and then not late, that's at least one, and the probability that it is not late and then late on the second one. But not late on both is no good to us, so we don't want that one. So what we need to do is work out these three probabilities this time. So late then late goes through 0.3 and then 0.7, which is 0.21. We've got the probability of it being late then not late, which is 0.3 times another 0.3, which is 0.09. And we've got that third one there, okay, which is not late and then late, which is 0.7 times 0.7, and that equals 0.49. So this time we've got three probabilities to add together, but because we've got a combination there, again, we just add them all up. So 0.21, 0.09, and 0.49. And altogether that adds up to, let's have a look, 8, 9, carry the 1, 4, 5, 6, 7. So 0.79 is our final answer for this one. Let's have a look at some with some fractions. Okay, so this question here says Mary has two bags of counters. In bag A there are 3 red and 2 blue, and in bag B there are 4 red and 3 blue. It says Mary takes at random a counter from bag A and notes its colour. She then takes at random a counter from bag B. Work out the probability that Mary takes the same coloured counters. Now again, this is an independent event because they're two different bags. It doesn't matter whether we take a red out of bag A, that's not going to affect the probability in bag B because that's a completely separate bag. So again, we can construct a tree for this. Now it starts talking about bag A, so I'm going to start with my tree being about bag A, and I'm going to label that up here, bag A. There we go. And again, it's red or blue. Now I've decided to stick with red and blue counters for all of these questions here, but there could be any sort of different combination of counters or pens or anything, or marbles it sometimes goes on about. We just need to make sure we read the story and construct our tree. So for red, there are 3 reds and there are 2 blues. That's out of 5 in total. So for red, it's 3 out of 5. And for blue, again, it's 2 out of 5, remembering obviously that those numerators have to add up to 5 in this scenario if you weren't given the information. So that's our pick out of bag A, and then we've got to have a look at bag B. So again, I'm going to label the second branches of the tree over here bag B, but again we have 2 different scenarios. Now we could take a red, in which case we're looking at this part of the tree, and again it's a red or a blue. And in that second piece of information there, let's highlight that, there are 4 reds and 3 blues. So there'd be 4 out of 4 plus 3 is 7, so 4 out of 7 this time, and it'd be 3 out of 7 for the blue. Of course, we could have taken out a blue out to start with, so we could be on this part of the journey, and again, there'd be a red or a blue, but nothing's going to change down there. It doesn't matter whether we take a red or a blue out. Red and blue are going to stay the same, so it's still going to be 4 out of 7 and 3 out of 7. And there we go, that's our tree constructed. And again, just thinking about obviously those second little sets of branches there, both are the same top and bottom, as it's an independent event, and it doesn't say anything changes. You know, it might say if so-and-so took a red in bag A, that the probability changes in bag B. If it doesn't state anything though, we always just assume that it's always going to be the same there, as it doesn't say anything's going to change. So it says here, work out the probability that Mary takes the same coloured counters. So again, just thinking about the logic here, like before we had red, blue and blue, red for different coloured counters, this time it's the same coloured counters, and there are two ways of doing that. We could get a red going through the 3/5 there, and another red going through the 4/7. So that is our two fractions that we're going to have to multiply this time. So if we do those, we get 3/5 multiplied by 4/7, and again times in the top gives us 12, and times in the bottom gives us 35. So there are 12 out of 35 ways of getting two reds. And then obviously thinking about the fact of the same colours, we could have two blues. So if I go through blue 2/5 and through the other blue 3/7, that's going to give us our second probability there using those two fractions. So if we write those down, we have 2/5 multiplied by 3/7, and that gives us 6 on the top and 35 on the bottom. So telling us there's 6 out of 35 potential ways of getting two blues. And again, finishing this question off, we've got two probabilities that we need to add together. So I'm just going to write down the sum this time. We've got 12 out of 35, and we need to add to that the 6 over 35. And 12 plus 6 is 18, and that is out of 35, again remembering not to add the denominators together there. So 18 out of 35 is going to be our final answer for this question, as our probability of getting the same colours. Remembering again though, you could get a nice easy one. It could say what's the probability of two blues, in which case we'd have just gone along that purple route and got 6 out of 35. Okay, so just thinking about obviously the slightly harder style questions here rather than just one straight route. Okay, so if you're able to do these, you're able to do most of those questions there. Okay, so when looking at mean, median and mode, we could just have this from a list of numbers. Now, no matter what list of numbers you're given and whatever averages you're looking for, it's always best to write them in size order, as that's going to help with most of the averages. So if we have a look at writing this in size order, we've got 3 as our smallest number, so we'll put that first. Then we have 2 4s, so we'll write them next. We have 2 5s, and let's see, we've got a 6. We've got an 8, and then we have 9 and 10. Now that's not necessarily going to help you with working out the mean, but it is going to help with part B and C where we're looking at the median and the mode. So to start with here, we're going to actually just work out the mean. Now if we add these all together to work out the mean, we get a total of 54. And when we're working out the mean, once we have the total, we just have to divide it by however many numbers there are. So if we count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, so there are 9 numbers, so we do 54 divided by 9, and we get an answer of 6. So the mean in this question is just going to be 6. To work out the median, we need to find the middle number. Now hopefully we just get 1 in the middle, but we'll talk about what happens if we don't. But let's just cross off numbers from either end. And let's see if we get a number in the middle, 1 more on each side, and we do, we get a median of 5. So this particular question just has a median of 5, and that's why we've put it into size order, so we can apply that method. Now if you do get 2 numbers in the middle, so say for example there was a 5 and a 6 in the middle and there was 2 left, you would just add them both together and then divide by 2, essentially finding the mean of 2 numbers. So add them together and divide them by 2, but obviously in this question we did end up with a number in the middle. Now we've got to work out the mode, and this is where I prefer actually underlining the numbers rather than crossing them out, because now we have to work out another average. So really I'm going to have to look behind all those crosses. Now thankfully I can just get rid of them, but obviously if you're in an exam you don't really want to be scribbling all over the numbers, so I would opt for underlining them if you have the choice. So looking at this then, we need to find the mode. Now you can see that there are 2 4s that are grouped together there, but there are also 2 5s. So there's not just one mode for this question, there's actually 2. So we would say 4 and 5 for this particular question, although usually when you're asked to work out a mode, there's normally only 1, but just in case there isn't, you can have 2. So there we go, that would be looking at just working out averages from a list, but of course you need to remember that you could be asked to work out these averages from a table as well. Okay, so we're going to start by having a look at averages from a table. So this table shows the mark for 30 students in a test, and it wants us to calculate the mean and write down the modal mark. Now to calculate the mean, it's quite nice and simple. If we have a look at this table here, this first row says that there are 2 14s, and if we add together 2 14s we get 28, so we can just times these together to find out what the total is. So that's 28. 10 15s times those together is 150. 2 16s is 32, 3 17s we'll have to work out, I think that's 51, 3 times 17 is 51, and the last one there is 13 times 18, so 13 18s is 234. Now if we add all this up, it'll tell us the total amount of marks that everybody got. So 234 plus 51 plus 32 plus 150 plus 28 gives us a total amount of marks there of 495. So that's their total, and it says that there are 30 students up here. Although if we didn't know that, we could add together this frequency column and we get a total of 30. So to find the mean, we just need to do 495, the total amount of marks, and divide it by 30. And that gives us a final answer there of 16.5. And don't forget, your answer has to fall in between the range here, which is between 14 and 18. So 16.5 is within that, it makes sense, we're happy with that. Now part B says to find the modal mark. Now the modal mark just means the mode mark, okay, the one that's the most common. And if we have a look at our table here, the one that's the most common is this one down at 13, and that represents 18 as the modal mark. So the modal mark would be 18. Okay, because 13 people got that, and that's the highest there in that frequency table, so 18. Now this question is very similar. It shows the height of 30 students. It says calculate an estimate for the mean, and then again write down the modal class interval. So the reason it says to find an estimate for the mean is because we can't get an exact mean because we don't actually know, particularly looking at just this first row, what that person's height actually is. It's one person between 130 and 140. There could be anything, 132, 138, anything in between. So what we do is we pick the midpoint. So in between 130 and 140 is 135, and we're just going to use that as an estimate for the height of that person. And we'll do the same for all the others, 145, 155, 165 and 175. And we'll just treat this in exactly the same way as we did before. So one person at 135, 7 people at 140, and we're just going to times across for all of these again. So one lot of 135 is 135, 7 lots of 145 is 1015, again I'm just doing this on the calculator, 8 times 155 is 1240, 10 times 165 we can do 1650, and 4 times 175 gives us 700. And again, from here, it's just the same process. We add those all together. So 700 plus 1,650 plus 1,240 plus 1015 plus 135 gives us a total there of 4,740. And again, it said that there were 30 students there, which we can find from the bottom. So finishing the sum exactly the same as before, 4,740 divided by 30. Will give us an estimate here for the mean, because again we have just guessed what their heights are as using those midpoints, which gives us 158. And again, that answer there has to fall in between this range here, which starts at 130 there and ends down here at 180. So it has to fall in between, so 158 centimetres. Now the next bit says write down the modal class interval. Now the word class just means group, so it's the modal group, which group is the most common, and that's here with these 10 people. So all I have to do is, and I've written over the top of it now, but all I have to do is write this group down here. So the modal interval, okay, is that exact thing there, and I just write it down word for word, 160 to, what was in the middle, h in this instance, to 170. And that would be my modal class interval just there. Okay, so the last one of these before you have a go. It says on an activity day, students play one sport, either football, hockey or tennis. And it said there are 120 students, 30 are boys, 12 of the 38 students who play hockey are boys, 35 of the 45 students who play football are girls, one of the girls is chosen at random, write down the probability to play tennis. So this is very similar to our last one in that we're going to have a very similar table. Okay, we're going to have a nice table drawn out. We've got boys, we've got girls, and we've got a total, which I'm now just going to label as T. Okay, you can write the full words in if you want. And then I've got 3 options and a total at the end. So we've got football, we've got hockey, we've got tennis, and again a total. And then I'm just going to label that as total, as I've got another T up there. Right, okay, so putting all the pieces that we've got there are 120 students. So let's put that in our total down there. It's 120 in total. We've got 30 of the students are boys. So in the boys column, total is 30. The next one there, we've got 12. Let's have a look. This has got 2 bits of information here. Look, it says 12 of the 38 students who play hockey are boys. So that says 12 of the people that play hockey are boys, and that's out of the 38 that play hockey. So 12 are boys. Let's have a look for the hockey column. 12 boys out of 38 down there. we've got this same piece of information here with the football. It says 35 of the 45 who play football are girls. So in the football column, we've got 35 are girls out of the 45. There we go, so that allows us to put 2 bits of information in. So now we can go about actually filling in the rest of this table. So let's have a look then. We've got the first column there, that has to add up to 45, so we're missing 10. So we've got 10 boys. And then going to go across the top here. So at the moment, along these two, we've got 22 so far. We need to get to 30, so that's an extra 8. Let's have a look where we can go now. We can go down this way as well. Okay, we've got 30 boys, so that's going to be 90 girls to make sure it adds up to 120. And where else can we go from here? We've still got this missing box here as well. So at the moment, these two, what do they add up to? We've got 40, 50, 60, 75, 83. That adds up to, we need to get to 120. So that is going to be an extra 37. And then we've also got the one above that now, and obviously these two in the middle. So moving down this way, we've got 12 there. We need to get to 38, so that's an extra 26. And we've got 8 here. We need to get to 37, so that's an extra 29. There we go. And as I said before, just a quick check that these still add up to 90. So 35, add 26 is 61, plus the 9, 70, 80, 90. Yes, that all adds up, so that's absolutely fine. Right, there we go. So that's our table filled in. And then let's have a look. It says one of the girls is chosen at random. Okay, so one of the girls is chosen. Write down the probability that they play tennis. Okay, so the language is different here, and this is important. It says one of the girls is chosen. So if we have a look, how many girls are there in total? There are 90. So one of those 90 girls is chosen. So our probability this time is going to be out of 90. Just got to watch out for the language there. What's the probability that they play tennis? Well, there are 29 there that play tennis. So that's going to be 29 out of 90. Okay, so obviously the language is different there. It said one of the girls is chosen, so that specifically, that dictates that you are having to choose from one of the 90 girls, and then out of that 29 of them play tennis. There's our probability. And again, as with all probabilities, you do not have to simplify that. You can just leave it as it is. Again, it's an important piece of information there. It tells us specifically that 29 out of 90 play. Not that that one does simplify, but if it does, you don't have to simplify it. Okay, although you wouldn't be wrong for doing so, but it's just going to waste a little bit of your time.
Okay, well done, you made it to the end of paper 2. Well done for staying all the way to the end. I hope you found that useful and helpful. Again, don't forget to subscribe to the channel, don't forget to like the video, drop me a comment if anything you'd like me to go over a little bit more, and don't forget to have the video saved so that you can have a look at the other papers as and when they come out. So there we go, I'll see you for the next one.